Okay, we have a circle, and there's a chord that is 6 centimeters long in the circle. So let me try to draw a beautiful circle here. Not so beautiful, but that's okay. Okay? And you have a chord that is 6 centimeters long. This will not be to scale. And it is 2 centimeters from the center of the circle. So this is 6 centimeters. Oops. And then this is, again, not to scale. This is 2 centimeters from the center. Now the question is, how long is a chord that is 1 centimeter from the center of the circle? So I'm going to draw another chord, not necessarily parallel. Let's just go like that. How did I know that that chord was going to be longer than the other chord?
Because it's only 1 centimeter.
Right, it's closer to the center, so we have that, and that is 1 centimeter in the center of the circle. We want to find out how long that chord is. Okay, so where do we start from here?
We're trying to find the length of that chord.
Yes.
Oh, okay.
So usually when we have chord, go ahead.
Could you use a proportion or no?
You can't use a proportion because that circle is changing at a non-proportional value rate. Yes.
When you draw a line from the center to the point of the chord 6 centimeters.
So like the end of the chord?
Yeah, the end of the chord.
So if I draw that line, like Emily's
Which
saying,
would be
what do I know about that
radius.
line? That is the radius. So that's the radius. Perfect.
And
Yes, and also the distance, the line that forms the distance between the chord and the center is a right angle.
So using Pythagorean theorem, you could do.
It's 3 and 2.
So this has to be 3 because it also bisects the chord. And then we could use Pythagorean theorem to get r, exactly. So we can go 2 squared plus 3 squared equals r squared. Now I'm not going to use a calculator here. We want to leave it in radical form. So everybody should get that we have r equals root 13. You okay with that? So we have 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. So we have r equals root 13.
Okay, so then you can do the radius to the other side
So-
of the chord on the opposite one.
So we have that radius.
And that will also be the same.
That'll be root 13. And then how would we find, what do we want to find now?
The length of you can find half of the length of the chord and then just divide, or
Okay, perfect. So I'll call that b. So then we'll go 1 squared plus b squared equals root 13 squared. 1 plus b squared equals 13. B squared equals 12. So b equals root 12. So b is root 12. So now how long is the chord?
Root 24.
Careful.
No.
2 times root 12. 2 times root 12.
That's true.
That is 2 root 12.
Wait, why wouldn't it be root 24?
Good question. Yeah, so why if you double root 12, if I double that, why doesn't it equal root 24? Because since the 12's under the root, okay, we want to double it. So to double it, really, we have to multiply it by root 4, right? 2 times something is the same as taking root 4 times something. So we actually have to multiply this times, if you want to double it, times root 4, because root 4 is 2. So actually doubling root 12 is the same as root 48. It kind of makes sense?
Yeah.
So it'd just be 2 root 12.
It'd be 2 root 12. I would leave it 2 root 12. And if you want to take 2 root 12 and go opposite, you could see that 2 root 12, well, 2 is the same as root 4 times root 12. And that's where I got that root 48 from.